Dear physics aspirants, right now I have the physics book of +2 level, and electromagnetic induction is the topic. And within this topic, we will discuss 6.10 AC generator. So induction is the word for electric and magnetism induction. So 6.16 or picture will provide you the AC generator mechanism. You will see the slip rings, alternating EMF, electromotive force, and carbon brushes, axial coil, and north-south. You will see here the magnets. Then when you study this topic, then you will find the generators. How work the generators? Generators work how you will understand when you study. AC generator, the phenomenon of electromagnetic induction, has been technologically exploited in many ways. It means it can be used in many ways. An exceptionally important application is the generation of alternating currents. So it is very important for your understanding that AC alternating currents is how generated by the generators, and what is the function mechanisms are working within the generators. The modern AC generator, generate means produce, with a typical output capacity of 100 megawatt, is a highly evolved machine. In this section we shall describe the basic principles behind this machine. Generator is a kind of machine, and we are going to discuss this machine with the topic electromagnetic induction. The Yugoslav inventor Nikola Tesla is credited with the development of the machine. Name is given here. Yugoslav inventor Nikola Tesla is credited with the development of the machine, as was pointed out in section 6.3. When you study the NCERT book of +2 level physics, then you will find. For more information, interactive animation on AC generator, you will see the http://micro.fsu.edu/electromagnet/java/generator/ac.html. When you visit this site, then you will find the interactive and animation on AC generator. Link is here. You will see this link and you can find the animations. If you are the student of physics, then you will make a project with the help of this link. One method to induce an EMF, electromotive force induction. This process is induction or current on loop, is through a change in the loop's orientation on a change in its effective area. These are the area. As the coil rotate in the magnetic field B, coil is rotating. The effective area of the loop, the face perpendicular to the field, as is A cos theta, where theta is the angle between A and B. Theta is the angle between A and B. This method of producing a flux change is the principle of operation of a simple AC generator. An AC generator converts mechanical energy into electrical energy. So AC generator converts mechanical energy into electrical energy. The basic elements of an AC generator are shown in figure 6.16. You will see the AC generator. When you study, if you are the +2 level students, then when you go to the physics book And when you opt the electromagnetic induction, then this chapter will definitely come, and it is required for your understanding for the examinations. Picture is given here. 6.16, it consists of coil mounted on a rotor shaft. Rotor shaft axle you will see here along with carbon brushes. The axis of rotation of the coil is perpendicular to the direction of the magnetic field. The coil called armature. The coil is also known as the armature, is mechanically rotated in the uniform magnetic field by some external means. External means, when you go to the generator, then you will see the machine operated by the diesel or petrol, and it can be run with the help of the outer external means. The rotation of the coil causes the magnetic flux through it to change, so an EMF, electromotive force, is induced in the coil. You will see the EMF. EMF is very important. The ends of the coil are connected to an external circuit by means of slip rings and brushes. You will see here. When the coil is rotated with a constant angular speed, symbol is here, and angle theta, angle will be theta, and an angular speed you will see here. Magnetic field vector, V vector is very important. So scalar and vector, when you study, then this will provide you V, and the area vector A of the coil at any instant t is a theta, and the symbol is here, angular momentum assuming theta d 0 degree and time 0. As a result, an effective area of the coil exposed to the magnetic field lines changes with the time. And from equation 6.1, the flux at any time t is, here is the symbol B, and B equals theta, B equals an angular momentum time is here. This equation will work. From Faraday's law, the induced EMF for the rotating coil of n turns is, then you will see the equation is here. When you study Faraday's law, in this chapter you will also study the Michael Faraday. Thus the instantaneous value of the EMF electromotive force is the same time as E is equal to NBA as angular momentum sine angular momentum T angular momentum, where NB angular momentum is the maximum value of the EMF which occurs when omega t is equal to plus minus 1. If we denote NBA angular momentum as E0, then E is equal to E0 sine angular momentum T. Since the value of the sine function varies between plus 1 and minus 1, the sign or polarity of the EMF changes with the time. Note from the 6.17 of the equation, when you see in this chapter, 6.17 is here, self-inductance. Within the self-inductance, you will see the formula. Here you will see that since the value of the sine functions varies between plus 1 and minus 1, the sign or the polarity of the EMF changes with the time. Note the figure 6.17 that the EMF has its extremum value when angle theta is equal to 90 degree, theta is equal to 70 degree, and the changes of the flux is greatest at this point. The direction of the current changes periodically, and therefore the current is called that alternating current. Alternate, changes periodically, alternate. Since angular momentum is equal to 2 pi v, equation 6.22 can be written as, you will see here, the equation is here, 2 pi vt E0 sine 2 pi vt, and v is the frequency of revolution of the generator's coil. Note that equation 6.22 and 6.23 give the instantaneous value of the EMF, and E varies between plus E0 and minus E0. Periodically we shall learn how to determine the time averaged value for the alternating voltage and current in the next chapter. Especially you will see here the alternating currents. How here the angle is 90 degree, 180 degree, 270 degree, 360 degree. Time is here. It is very important for your understanding stage 1, 2 and 3 to 5. Alternating EMF generated by the loop of wire rotating in a magnetic field. In commercial generators, the mechanical energy required for rotation of the armature is provided by water falling from a height. Hydroelectric, for example, from dams. These are called the hydroelectric generators. Alternatively, water is heated to produce steam using coal. The other sources, the stream at high pressure produces the rotation of the armature. These are called thermal generators. Steam used. So hydroelectric generators, thermal generators instead of coal. If nuclear fuel is used, we get nuclear power generators. Modern day generators produce electric power as high as 500 megawatt, i.e. one can light up 5,100,000 bulbs. In most generators, the coil are held stationary and it is the electromagnets which are rotated. The frequency of rotation 50 Hz in India and uncertain countries such as USA it is 60 Hz. So in India 50 Hz and other countries as well as USA 60 Hz. So Hz, and here is the one solution, problem and solutions. We will meet in next session with a lot more. And here the migration of birds, and the topic is gear summary of the electromagnetic inductions. So students and aspirants, you will see here it is very important. And this is so as a generator and generator is completed, we will meet in next session with a lot more. Till then, thank you very much.